Today we will discuss OSPF. OSPF is a link state routing protocol, and it has a protocol number of 89. Um, OSPF is very commonly used within different networks. So in this video, we will touch base how to form OSPF neighborship, and we will discuss different scenarios and different trouble tickets, just to have a better understanding of the things we can check when we are farming OSPF neighborship. So let's discuss some of the OSPF neighbor states that it goes through when forming neighborship. So when we configure OSPF, it starts with downstate, which means no hello packets have been transmitted. Then it goes to attempt. Only if it's a non-broadcast multi-access network. So if we have a broadcast network, then it goes straight to init. And in init state, it basically means that it has received a hello packet from another router, but there is no bidirectional communication between them. So when there is a bidirectional communication, it goes to two-way state, which basically means both sides have received hello packet. And in case of multi-access, in case of broadcast network, if it's not point-to-point link, then it goes to DR election here. DR and BDR election here. So after this process is done, it goes to basically X start. So which basically means that so it basically sync link state database in this type, in this state. Once then it goes to exchange state, where it exchanged link state database using DPD packets, database description packets. So the router will send database description packets to each other. Then it goes to loading state. If there is any LSAs that are recently added in either of the router, that will be exchanged in loading state, then it goes to full state. So full state means adjacency is established between two routers. Okay, for purpose of this lab, we're going to use we'll be using this simple topology R3 and R5. We'll see how they can make OSPF neighborship with each other, and after that we'll see some troubleshooting steps that we can use to determine if adjacency has not established. And there are some prerequisites to establish OSPF neighborship. There are a few things we basically need to check, make sure that these things are there when we are forming OSPF neighborship. So first thing that is very important, router ID must be unique. Okay, so these are a few things that we must need to match. We must need to check, sorry, when forming OSPF neighborship. So router ID must be unique on both in OSPF whole domain, and interfaces must be on the same subnet. So when we say same subnet, it means that, for example, if one side is /32 and the other side is, for example, /24, which is not, you won't see this in a production network, but so to understand this, as long as both IP addresses are within the same subnet range of the lower subnet, the adjacency should form. And very important, we must check the MTU size of OSPF interface, uh, because OSPF does not support fragmentation, and area ID must match between the two neighbor. And we'll discuss this one later. The DR. So this just means that if a DR is needed, it should match on both routers. So hello and dead interval should match. Authentication type parameters must match, and also area type flag must match. For example, if one is stub area, the other side, it should also be a stub area. One is NSSA, the other should also be NSSA. So let's do the configuration now. So basically, this is our lab that we will configure. I'll just put it here, and let's start configuring. So we have this interface that connects to R5. So we're going to configure this interface. So we'll give it 10.3.5.1, 255, 255, 252. And we'll just go on to the other side. And just so that we'll just enable debugging. And we'll just configure this side as well. So after configuring this, we can see that the neighborship is up. So these are all the states that we discussed. It goes through, and the neighborship is up. And we can verify that using show IP OSPF neighbor. So you'll see that this is where it's up. Now it says BDR because we haven't specified whether it's point to point or not. So if we go through GI 0.3, we'll see that the network type is broadcast. So you don't normally see DR or BDR if network type is, for example, in this case, the network type is point to point. We can check here. Network type, point to point, and network type, broadcast. So that's the difference. So there are a few trouble tickets that we can check, and I will be discussing this in the next videos. And basically we will check. Basically, we'll see why the neighborship is failing, and we'll discuss few cases and troubleshooting as part of that. Thank you so much for viewing this. I hope you like it, and if you can subscribe to me, that will help me to create more content. Thank you so much.